Alright, today we're going to start on a couple of sections on identities, and we're going to deal mostly with trig identities. These identities help us rearrange equations so that we can solve them easier, and there'll be certain ones that you're going to have to memorize. First of all, an identity is an equation that's always true. You know what your identity is. You know you have an identity in Christ, and that's always true. The math identities are the same thing. For example, we always know that no matter what we multiply times 0, we're going to get 0. And no matter what we multiply times 1, we're going to get that number back. Always. Those are identities. You have to prove an identity to show it's always true. You can't just assume it. We're going to work on proving some identities using ones that we memorize. Now, the first identities we're going to look at are called the Pythagorean identities. Now, you know about the Pythagorean theorem, and you also know about some trig functions. So let's look at some trig functions. If we set up a triangle, let's call this one y and this one r, we know that we have some trig functions. We know that the sine of theta is the opposite over the hypotenuse, and we know that the cosine of theta is the adjacent over the hypotenuse, and that the tangent of theta is the opposite over the adjacent. And we know we have some reciprocal functions too, that the cosecant of theta is the hypotenuse over the opposite, and the secant of theta is the hypotenuse over the adjacent, and the cotangent of theta is the adjacent over the opposite. Okay, these are all things that you should know cold. You know those without having to worry about any of it. You also know from the Pythagorean theorem that if we look at this triangle here, this is a right triangle, then we know that x squared plus y squared equals r squared. Remember, leg squared plus leg squared equals hypotenuse squared. Well, we can combine these two by rearranging this equation here a little bit. So let's look. What happens if we divide this whole thing through by r squared? Well, that gives us x over r squared plus y over r squared equals 1. Well, if we look at our trig identity, or trig functions here, we can look and replace this and see that this means that the cosine squared of theta, this just means we're taking the cosine and square it. We just write it with the little exponent there, if you recall. And sine squared theta equals 1. This is a Pythagorean identity for trig, and you must memorize it. We use these to go with what we know from the Pythagorean theorem and get a trig identity. Let's try if we start with that again. We have this again, but this time instead we divide through by x squared. We're going to get 1 plus y over x squared equals r over x squared. So we look over here. Well, y over x is tangent, so that gives us 1 plus tangent squared. And then we look what r over x is. And r over x is secant. There's another Pythagorean identity. Now, do you have to memorize this one? You need to know it, but if you know this one, and look at this one, if we divide this one through by cosine squared, we're going to get this equation. So this one is essential that you memorize. This one, you need to be able to recognize it, and you need to know it, but it's not quite as essential as this one. This is probably the most important trig identity you'll ever memorize. So let's try this one more way. Let's see if this will show up. If we divide through by y squared this time, we end up with x over y squared plus 1 equals r over y squared. Again, look over here, x over y is cotangent. So cotangent squared plus 1 equals, and r over y is cosecant. And here's our last Pythagorean identity. So these are the three Pythagorean identities for trig. Again, this top one here in red is the most important one you need to know. These other two you can get by either dividing this equation through by cosine squared or dividing it through by sine squared. You'll get these two equations here. Go ahead and look on your paper, pause this, and try to go from this equation to these by dividing by cosine squared first and sine squared second. All right, so once you've figured out how to do that and you've got those memorized, we can use these identities to prove other identities. Now, the thing about proving identities is when you prove an identity, you start with the most complicated side and get to the other side. You cannot work on both sides. You must work on only one side at a time and get to the other one. So let's look at this one. What if we have this identity here and I ask you to prove it? Okay, so it's a proof, so we need to start with the most complicated side and work with it until we get to the other side. So we're going to leave this side alone. That's where our end goal is. So we need to work with this side till we can get it. Well, what happens when you have fractions? Well, we want a common denominator. So what's our common denominator? Our common denominator is secant theta minus tangent theta times secant theta plus tangent theta. That's our common denominator. So how are we going to get these like that? Well, what do we do with common denominators? We multiply by whatever we have left. So for this one, we're going to multiply by secant theta plus tangent theta over secant theta plus tangent theta, if you can read that. And this one we're going to multiply by secant theta minus tangent theta over secant theta minus tangent theta. Remember, you got to multiply by 1 for it to stay the same. So once we multiply those through, we end up with secant theta plus tangent theta minus, and then here we've got secant theta minus tangent theta all over our common denominator, secant theta minus tangent theta times secant theta plus tangent theta. All right, so we're starting with this side and we're working through it and simplifying it. So we have secant theta minus secant theta, so that goes away. And then we have tangent theta minus negative tangent theta, so that gives us 2 tangent theta on the top. And on the bottom, if we FOIL this out, we get secant squared theta minus tangent squared theta. Now, we look at this and we say to ourselves, you know, if I have a secant squared and a tangent squared together like this, there's some Pythagorean identity that shows me that. Well, that's true. We know that 1 plus tangent squared theta equals secant squared theta, always. It's Pythagorean identity. We just proved it a minute ago. So now we can rearrange this and we see that 1 equals secant squared theta minus tangent squared theta. Simple algebra, just subtract tangent squared from both sides. So that means that this bottom part here is equal to 1. So this says 2 times the tangent of theta over 1, which is equal to 2 times the tangent of theta, which is what our end goal was up here. And so we're done. Now, when we're looking for this whole work, every bit of this is your answer. You can't just say, this is the box, here I am, that's the end. Those of you who like to just list the answers for your homework as you scribble on scratch paper all over the place, that's not going to work for these. You have to have all this work out to show what you've done. You did a proof. You didn't solve a problem. All right, let's try one more. What if I ask you to prove that the cotangent of theta plus the tangent of theta divided by cosecant squared of theta equals tangent theta? Well, we don't have any tangent squareds, and sometimes it's easier to work with sines and cosines, so let's try getting everything in sine and cosine form first. Remember, we've got to start with the most complicated side and work with that to try to get to this end goal. So we'll put these in sines and cosines. So we've got cosine theta over sine theta plus sine theta over cosine theta, all over 1 over sine squared theta. Now, what do we do with fractions? We get a common denominator. So what's our common denominator? Common denominator is sine times cosine. So we're going to multiply times cosine theta over cosine theta here, and sine theta over sine theta here. Remember, that's just multiplying by 1, so that gives us our common denominator, which is what we want. And dividing by 1 over sine squared is the same thing as multiplying times sine squared. So that just moves up there. We get our common denominator. We have cosine squared theta plus sine squared theta over sine of theta cosine of theta. All right, right here, what do we know? We know by those Pythagorean identities that cosine squared plus sine squared, or sine squared plus cosine squared, either way, equals 1. So what do we have on the top here? We have 1. So that means we have sine squared theta times 1 over sine of theta cosine of theta. Well, one of those signs can cancel, and we're left with sine theta over cosine theta, which we know is tangent. And we've got our end goal there. So we proved it all out just by rearranging using our identities and definitions and common denominators and things. Make sure you've read this section and looked over it, because we're going to be proving identities in class the next day.